Hey everyone, welcome back. Houston Math Prep here. We are doing partial sums of arithmetic series. So we have a list of terms and we're adding them all up, not an infinite list of terms. Partial sums means we're stopping at some point. But here I've got a list of terms. I'm adding 1, then 2, then 3, then 4, skipping a few, more than quite a few. And we are ending at 1,000. And if I want to add up the first 1,000 terms, I either need to have computer or I need to be an amazing typer on a calculator, or I need to know how to just simply do partial sums of an arithmetic series. The idea here is looking at how do you group the terms to make this simpler for you to do without the assistance of a ton of technology. Some people looking at this may say, well, maybe I could group the first 10 together, and then I could group the next 10, or I could group the first 100 together somehow, and they try to break it down into smaller pieces. Well, here's how we're going to do it. We're actually going to group these together not in blocks of 10 or 100 or 50 or 500. We're actually going to group them together from the beginning to the end. So I'm going to go ahead and look at pairing together my 1 and my 1,000, and they're going to be a pair together. And then I look at pairing from the end next, my 2 and my 999, they're going to be a pair. And then my 3 is going to pair with the thing that isn't really written before it, right? But that's a 900 and a 98. And then I would take 4 and I would pair it with 997, etc. So we're pairing them from the outside. Okay, so the idea is, what is the value of each pair? The value of each pair, if you can tell, 1 plus 1,000 and 2 plus 999 and 3 plus 998, those all add up to 1,001. So every pair, if I pair them that way, they're going to add up to 1,001 because this is arithmetic. This will not work if it's a non-arithmetic series. You're going to have to figure out some other way to do it. But because it's arithmetic, we're always going up by the same amount. If I pair them from beginning to end, going outside in, they'll always add up to the same number. And then the question just simply left is, how many pairs do I have? If you think about, well, if I had 1,000 shoes all in a pile, and let's assume they all have a match, and I haven't lost any of them, then 1,000 shoes are going to give us 500 pairs of shoes, right? So I have 500 pairs, and each of those pairs is worth 1,001. So if I want to know the sum of this entire thing without typing lightning fast like I'm the Flash, then I simply take the number of pairs times the value of each pair, and that will give me my answer. And it turns out that it's 500,500 for this one. So how will we write that more in math speak rather than when I say the value of each pair and how many pairs? So we will go ahead and use a formula that the sum of the first certain number of terms, this partial sum of n terms, so we need the value of each pair. And the value of each pair is just going to be, well, it's the first term plus whatever the last term is, right? So that's what we did. That's the value of each pair. That's the 1,001 part. And then how many pairs we had was just simply how many terms we had, but cut in half, right, to make it pairs. So that's really the number of terms we have, just simply divide by 2. So this really says that the sum of the first n number of terms, so many terms, is just going to be the number of pairs times the value of each pair, and that's what this expression says. Let's look at another example. We've got our formula up here if we want to use it. I've got 3 plus 6 plus 9 plus 12 plus, skip a bunch, and then we have 597 plus 600. So if I look at what is the value of each pair, pairing from beginning to end, you can see that if I take 3 plus 600, and then 6 plus 597, and then 9 plus, this would be a 594 in here, right, that we haven't written down, etc. But so the value of each pair, in other words, the A1 plus the AN, of this is going to be 603, right? That's the value of each pair. And then how many pairs do we have? So you want to be careful here. Before, when we had 1,000 terms and we cut it in half, it was 500. You look at this and you go, the last thing's 600, so that means I have 600 terms, and that is not okay. We don't actually have 600 terms because this time we're counting by 3. How do we actually figure out how many terms we have? Well, if we're counting by 3s, then that means the number of terms we have is actually 600 divided by 3. In other words, we actually only have 200 terms. Okay, so when we figure out the number of pairs, so that tells us that n divided by 2, the number of pairs, we would have 100 pairs of terms if we have 200 terms. Okay, if you're not sure, you can always use, remember we had our formula that was a sub n equals a1 plus n minus 1 times the common difference. That was for arithmetic sequences, right? And if you want to figure out the number of terms that you have, you can always use this to figure out the number of terms. You'll just be solving for n. Okay, so I'm going to go ahead and do that real quick, even though we already know, just so you've seen this in case it's hard to interpret how many terms and how many pairs you have going on here. So in this example, my a sub n, my last one is 600, right? And my first term is 3. Plus n minus 1, and I know the common difference. I'm going up by 3 each time, so I'm going to go ahead and put 3 in there, and then we just go ahead and solve this, right? So if I go ahead and distribute my 3, so that would be 600 equals 3 plus 3n minus 3. You can see that the 3 and the minus 3 drop off, and then if you divide by 3 on both sides, we'll get there's 200 terms. Now remember, when you do this and you use this expression, that's the number of terms. Don't forget to divide by 2 to tell the number of pairs. So the answer for this one, our partial sum, we're going to have the number of pairs is 100 times the value of each pair, which is 603. And if we do that multiplication, then we'll get 60,300 as our sum for all of these terms together. Okay, looking at another one, we have 65, we're going up by 5s, and then we're stopping at 500, okay? So obviously, we can tell right away, I think in all of these, what is the value of each pair, right? Just going from the outside in, you should be able to see that the value of each pair is 65 plus 500, in other words, 565, right? So that is the value of each pair. That's this part. We need to figure out how many pairs, but first we probably need to figure out how many terms. We're counting by 5s, but we're not starting at 5. We're missing some terms counting by 5s, right? Think about, I would start by saying 5, 10, 15, 20, etc., right? So we need to figure out counting to 500 by 5s, but missing several terms at the beginning. So we might use, again, our formula for an arithmetic sequence to do that. So if I use this, I stop at 500, I start at 65, plus n minus 1, times d, and I'm going up by 5 each time, so that is a 5 there. And if I distribute, then I'll get 500 is equal to 65 plus 5n minus 5. So here I have 65 minus 5, that's 60, so I'm going to subtract 60 from both sides. Here we'll get 440 is equal to 5n, and then if we divide by 5, we will get that n is actually 88. We have 88 terms, so our n divided by 2, which is what's in the formula, is actually this 88 divided by 2, which is going to be 44. So we have 44 pairs. Each pair is worth 565, so our sum is going to be 44 times 565. And that will give us 24,860 for this one. Okay, let's look at one more. Here's one with decimals just to give you an additional example. So we've got 5, 5.2, 5.4. You can tell we're going up by 0.2 each time. So we'll make a note of that. My difference is 0.2. We're counting by 0.2s from 5 to 20. Right, so obviously we can tell what the value of each pair is. If I take the first term plus the last term, and this is arithmetic, then that's going to give us the value of each pair is 25, right? 5.2 plus 19.8, etc. We'll get 25 for each of the pairs. Figuring out how many terms we have will help us figure out how many pairs we have. So if I plug in this info, a sub n is 20. Equals a sub 1, my first term, which is 5, plus n minus 1, times my common difference, which is 0.2. If I distribute my 0.2, I'll get 20 equals 5, plus 0.2n minus 0.2. This 5 minus 0.2 would be a 4.8. So I'm going to go ahead and subtract 4.8 from both sides. And then that is going to give me 15.2 on the left side. And I will get 0.2n left on the right side. So we'll have to divide by 0.2. And if we divide by 0.2, we should get that n is 76. So if n is 76, then that means the number of pairs that I have would be half that. Half of that is 38. So my sum then will be 38 pairs. Each pair is worth 25. And 38 times 25 is going to give us 950. As always, thanks for tuning in. We'll see you in the next video.